Hello Algebra 2 students, welcome to the first part of section 7-5 operations with function. Today you're gonna learn two objectives. Number one, how to add, subtract, multiply and divide functions. Number two, how to write and evaluate composite functions. You can perform operations on functions in much the same way that you perform operations on numbers or expressions. You can add, subtract, multiply, or divide functions by operating on their rules. The addition operation of two functions, take the two functions f of x and g of x. To perform addition on those two functions, f plus g of x is defined by the rule f of x plus g of x. Similarly, subtraction, f minus g of x can be extracted and written in the form f of x minus g of x. The multiplication operation, f g of x is simply f of x times g of x, and the division operation, f over g of x is the quotient of f of x over g of x, but you have to be aware of the domain of this operation because the denominator g of x cannot equal 0 because division over 0 is nonsense. The first two operations. Example 1, adding and subtracting functions. In this example, guys, we given two functions, f of x defined by this rule and g of x in blue defined by that rule. We need to find the addition f plus g of x and the subtraction f minus g of x. How do I operate the addition of two functions? Simply, we need to start with the rule f plus g of x is simply f of x plus g of x. Direct substitution, guys. This is equal f of x is 4x squared plus 3x minus 1 plus g of x. G of x is given by the rule 6x plus 2. In the next step, we're going to combine like terms. Whenever you see any like terms, you combine them. 4x squared is a unique term, so we're going to copy 4x squared. 3x and 6x are like terms. 3 plus 6 simplifies 9x. Negative 1 and plus 2 are also like terms. Both are constants. Negative 1 plus 2 simplifies plus 1. So guys, this is f plus g of x. Very easy. Subtraction. F minus g of x is defined by the rule f of x minus g of x. Direct substitution. Guys, I'm gonna do a mistake on purpose, and your job is to figure out what is my mistake. F of x defined by the rule 4x squared plus 3x minus 1 minus g of x. Be aware, I'm gonna do a mistake right now. Minus g of x minus 6x plus 2. What was my mistake? Yes, absolutely correct. My mistake is this minus is in front of g of x, so I have to keep g of x in parentheses. This is the importance of parentheses because, guys, actually this is the distributive property. I need to multiply this invisible negative 1 by every term inside. So this is simplifies. I'm gonna copy the first thing for x squared plus 3x minus 1 And now minus times 6x, it's minus 6x. And minus times plus 2, it's minus 2. Now combine like terms. If you find any 4x squared is alone. 3x and minus 6x are like terms. Combine them together, they give us negative 3x. And also we can combine negative 1 and negative 2, they combine negative 3. So guys, adding and subtracting functions are very similar to adding and subtracting numbers. Same idea. The other two operations we need to perform on functions are multiplying and dividing functions. Take this example. We given two functions, f of x in red and g of x in blue. First, we need to find the product of the two functions. Later, we need to find the quotient of the two functions. What is the rule of multiplication? The rule of multiplication, f g of x is f of x dot g of x. It's regular multiplication. Now guys, it's time for substitution. I'm gonna substitute f of x 6x squared minus x minus 12, everything this time in parentheses because we're doing multiplication, times g of x is 2x minus 3. Many ways to perform this multiplication. We can use distributive property. We can do distributive property in different ways. Guys, you can take this term and multiply it by this binomial. Later this term by this binomial. Later that term, negative 12, by that binomial, and do distributive property another 3 times. Or you can distribute the binomial into the trinomial. You can take the term 2x and multiplied by this trinomial 6x squared minus x minus 12, and later you take minus 3, this negative 3, and you multiply it by the same trinomial 6x squared minus x and finally minus 12. Yep. Now distribute property 2 times. 2x is multiplied by every term of this trinomial, and the negative 3 is multiplied by every term of the same trinomial. 2x times 6x squared, it gives us 12x to the power 3. 2x times negative x, it's minus 2x squared. 2x times negative 12, it's negative 24x. Similarly, distributive property, negative 3 times 6x squared gonna be negative 18x squared. Negative 3 times negative x, it's a plus 3x. And the negative 3 times negative 12 gonna be 36. Now it's time to combine like terms. 12x cubed is a unique term, 12x to the power 3. Guys, I need to identify like terms. Negative 2x squared and the negative 18x squared are like terms. They add together negative 20x squared. I see negative 24x and 3x are also like terms. These two terms are like terms. Negative 24 plus 3 simplifies negative 21x. And finally, guys, we have this 36 alone, so it's a plus 36. This is the product of f of x times g of x, or fg of x. The product of the two functions is this beautiful polynomial. Now, what about the quotient? The rule of the quotient is simply the top function, the one in the numerator, f of x, divided by the one in the denominator, g of x. But be aware, guys, there is very important condition this time. G of x is not equal to 0. You know the reason? Because when you divide by a 0, it's a math error, it's nonsense. So we cannot take any value that makes g of x is equal to 0. We're gonna exclude any x value that makes g of x equal 0 from the domain of this quotient. Now guys, substitution. Let's get started with f of x on the top. We have 6x squared, 6x squared minus x minus 12. G of x down in the denominator, 2x minus 3. How do I find the domain of that function? The domain of that function is all real number except what makes 2x minus 3 equal 0. So we can take it outside. You can equal 2x minus 3. This is cannot equal 0 actually. So x cannot equal 3 over 2. So all real numbers are the domain of this quotient except x equal 3 over 2. So x cannot equal 3 over 2. How do I proceed in this quotient? How do I simplify this quotient? By factoring. I can do nothing for 2x minus 3. It's already a linear binomial, already in the simplest form. But if you take a look on the numerator, you will find it's a quadratic trinomial. So we can try factoring this, the product of two binomials. You need to try, guys, because there are many different scenarios. When you factor 6, it might be 3 over 2, it might be 6 times 1. Also, the factors of 12 are 3 pairs. It can be 12 times 1, it can be 6 times 2, it can be 3 times 4. So you need to be lucky when you try. I'm gonna try 3x times 2x. The last signal is negative. It means the signals are different, one of them negative and one of them positive. I'm gonna start with the positive one. This one gonna be positive, this one gonna be negative. Yep. How do I factor 12? There are many scenarios to factor 12. I'm gonna try the scenario of 3 times 4. So if I try 3 times 4, guys, how do I know if my factoring is correct? You need to check the outers and the inners. If the outer and the inner gives you the middle term, it means the factoring is pretty correct. So let me try that. The outer, 3x times negative 3, it's negative 9x. Negative 9x. And the inner, 4 times 2x, it's a plus 8x. The sum of negative 9x and 8x, it gives us the negative plus 8x, it gives us negative x. Guys, congratulations, this is exactly the middle term of this trinomial. So my factoring is pretty correct. And now, guys, it's time to simplify this answer and put it in the simplest form. We have a common factor, a common binomial, 2x minus 3 on the top, and the same binomial 2x minus 3 down. So we can simply cross out this one with this one and put our answer in the simplest form. It's gonna be 3x plus 4. Don't forget our condition. Our condition is x doesn't equal 3 over 2. X can be anything except 3 over 2. So guys, this is the basic operation, the basic 4 operation of function. See you in the second part. Thank you.